Alright, welcome back. Today we're going to be doing the Recursion-1 section. So, this section is based around, you'll never guess, recursion. And so first we need to talk about what recursion is. So, let's go over and talk about it. So, basically, recursion in programming is just when you have a method that calls itself. So inside the method's body, it's going to invoke that method. It's going to use the same method that you're defining, which sounds kind of weird at first. So let me give you some examples. So let's say we had a method just called like print nums or something, and it's going to take an int in. Okay. So what I'll do here is I'm just going to write a method first. Okay. I'm not really going to explain it first. Then I'm going to show you a few examples, and then I'll go back and explain it. Okay. So I'm going to say if n equals 0, I'm just going to say return. So, by the way, in programming in Java, if you have a method where the return type is void, that just means you don't return anything. So, if you want to end the method, you can just say return and you just don't put anything. But okay, so if n equals 0, I'm just going to stop the method. Okay. So, but otherwise what I'm going to do is I'm going to print out n, and then I'm going to call print nums, but I'm going to pass it in minus 1. And so this, notice I'm calling itself. This method is calling itself here. And so if I say print nums and I pass it 5, what it'll do, if I run this, it'll print out 5, 4, 3, 2, 1. And if you want to pause right now and try and think about why that is, you can. But I'm going to go ahead and explain it now. So let's think about what's happening here. So actually let's do it with 4 just so I don't have to do as many iterations. But okay, so 4 prints 4, 3, 2, 1. So I call this with 4, right? So I call print nums, it gets past 4. Okay. So then we're running through the method, n equals 4, so it says if n equals 0, return, well n is 4, so it's not 0. So then I print out n, which is 4, and then I call print nums on 4 minus 1, which is 3. Okay, so now I call print nums 3, and now n equals 3. N equals 0, nope. Then I print out 3, and then I call print nums on 3 minus 1, which is 2. Okay, so then I'm going in again, print nums n equals 2. Does n equal 0? Nope. Print out 2, and then call print nums on 2 minus 1, which is 1. Okay, so now I'm calling print nums with n equals 1. Does n equal 0? Nope. So print out 1, and then call print nums on 1 minus 1, which is 0. Okay, so now I'm entering print nums n equals 0. Does n equal 1? Yes, so return. So just stop the method. So you can see that's how this call here, this one call to method to print nums 4, is working. It's recursively calling itself again. And of course, whenever you recursively call, you have to change the arguments a bit, right? Because if I just called print nums in again, then in would never decrease, and it would just go 4, 4, 4, 4, 4, 4, 4 forever until my program eventually crashes because of something called a Stack Overflow error. And what this basically means is that you've done too much recursion, basically. You've called, like, a method that has called itself over and over and over again, and it can't even keep track of how many calls you've made to that method because you've done like thousands and thousands and thousands. And you just you've made too many calls. So a Stack Overflow error will only come up if you've done something bad. It's not going to like come up naturally because your code's too complicated or something. It'll only come up if you actually do something, bad, like that doesn't make sense, that doesn't work. So, yeah, so you have to change the arguments a little bit each time, or otherwise it'll just be the same call over and over again forever. So, yeah, that is an example of recursion. So, let's go ahead and try one here. And actually, wait, before we do that, let me make this call a little more complicated. Let me add something to this call that's gonna make it a little more interesting. Okay, so what I'm gonna do is after this call, so I print out inside the body of print nums, I print out in, then I call print nums with in minus 1, and then I'm going to print out in again. Okay, so if you want to pause and think about what this might do, you can, but I'll go ahead and show you now. So it prints out 4, 3, 2, 1, and then 1, 2, 3, 4. So it counts down and then it counts up. And again, if you want to try and think about it, I really encourage you to do. But let's think about what's happening here. And now it's starting to get a little complicated. So basically, I don't exactly know the best way to draw this out, but I'll try to use this to help me explain it. So basically, we call the function, we call printNums with 4. So I'm just going to call that p of 4. Okay, and so then does n equal 0? No, it doesn't. So I'm just going to print out 4. So I'll just use SOPL. That's short for system.out.println, which is what it says there to print something. So then I print out 4, right? Print out 4 if we're just going through the body of the code. So I call, I start with a call to print nums4. And so then I print out 4, which is in. And then I call print nums3. Okay, so then print nums3 comes over and starts a whole new call of print nums. So I'll draw a line here and say that this is, okay, so now I've entered a call of print nums3. Okay, and then, so I'll just put a colon here when I'm entering. So then I print out 3. You can see that all of my prints so far agree with the output, so then I print out 3. And then I call print nums2. And when I do that, it causes the method to be called again, of course. And so now print nums2. So then I print out 2, and then I do print nums1, and then that causes a new call once again. I enter print nums1, and then I print out 1, and then I do print nums0, and we all know that print nums0 is going to do nothing, so I'm not going to show that. Okay, and then, okay, so this line has been evaluated now, so then I just go on to the next line, which is print 1 again. And now, okay, so this whole thing that I was just doing, this whole thing right here that I was just doing, was all just to evaluate this single line of code. So now that this single line of code is evaluated, then I will go on to the next line, which is print out 2. Okay, and now this whole thing, which in turn caused this whole thing to be executed, this whole thing here was just to execute this line of code. So now that this line of code has been executed, I do the next line, which is print out 3. Okay, and now this whole thing here, which in turn really included all of this stuff by further recursion, but that whole thing was just to execute this line here. And now that that line's been executed, I do the next line, and I print out 4. And now I've reached the end of the print4 call, and I'm done. So that is basically how recursion works. If you need to trace it out like this on any other problems, feel free to do so. All right. So now let's get into some examples. Or I guess not examples, but some actual problems. Okay. So given n of 1 or more with the factorial, return the factorial of n, which is n times n minus 1 times n minus 2 times, etc., down to 1. Compute the result recursively without loops. Go ahead and pause and try this. Okay, so here's how we can do this. Basically, what we want to do is I want to just say return n times, so, well, okay, so basically let's first realize that n factorial is something that you probably realized, but I'll just write it out explicitly. N factorial is equal to n minus 1, is equal to n times n minus 1 factorial, except when n equals 0, because if n equals 0, then this error just implies that n factorial equals 1. because 0 factorial equals 1. Oh, and actually it says n is going to be 1 or more, so we'll actually start that as 1. So when n equals 1, you have 1 factorial equals 1. Okay, so we'd like to just say, basically, return, we know that n factorial is the same as n times n minus 1 factorial. So that's great, but the only problem here is what about when n equals 1, right? Because this is just going to keep going on forever if we think about it, right? It's going to call this, which is going to call something, which is going to cause factorial to be called, and every time I'm calling factorial. Like I never have a return anywhere, like how in my printnums method here I had a return. I never have something that's going to make this stop. And so when do I want it to stop? Well, I want it to stop when n equals 1. When n equals 1, I know that n factorial is just 1, because 1 factorial is 1. And so that is how I could do this problem. And they did it in the same way. So, yeah, and so basically this thing here, it probably, I think it's, yeah, it said that in the comments as well. So this thing here, this case where, okay, like the inputs are so obvious that I know what the result's going to be without doing any recursion. This is called your base case. So n equals 1 is my base case, because if n equals 1, I don't do any recursion, I just return a already known result. So, and then this thing, you could call this, I don't know, your recursive call or something. Do they have a name for it? Yeah, okay, just it's recursion. So that is how we could solve this one. Now, of course, this problem could be done with loops, and it's actually more efficient to compute the factorial of something using loops. But these are just, again, these are just exercises in recursion, and we'll get to some later problems that are much better done in recursively than with loops and stuff like that. Okay, so we have a number of bunnies, and each bunny has 2 big floppy ears. We want to compute the total number of ears across all the bunnies recursively without loops or multiplication. So this is an interesting problem because it's very obvious to do this with multiplication, but it asks to do it recursively. So try and pause and do this one. Okay, so the strategy is basically to say if we have n bunnies, then the number of ears we have is the same as 2 plus the number of ears we'd have with n minus 1 bunnies. That's the idea. So if we have 0 bunnies, first of all, and honestly, I'm going to dehumanize these bunnies and call them n. So if n equals 0, then we have 0 ears. But otherwise, we have 2 plus the number of ears we would have if we had 1 fewer bunny. So that's how we could do this one. The hint is, yep, tells you the base case, and then the solution is pretty much the same. So, yeah, that is how we could do this one. It's okay if you didn't like think of this solution right away. It takes a while to get in the mindset of recursion when I was first doing these problems. Like I could understand the solutions, but I just couldn't get to them on my own. So yeah, it might take a while to like start thinking recursively and figuring out like this problem that is so obvious that we don't even think about it much because we just multiply by this number by 2. Think about how you could do that recursively, and it's yeah. So it kind of takes a while to get into that mindset. Okay, the Fibonacci sequence is a famous bit of mathematics, and it happens to have a recursive definition. The first 2 values in the sequence are 0 and 1, essentially 2 base cases. Okay, they give you a bit of a hint there. Each subsequent value is the sum of the previous 2 values, so the whole sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. Define a recursive function that returns the Fibonacci number, with n equals 0 representing the start of the sequence. Okay, pause and try this. Alright, so Fibonacci, this is an example. So the Fibonacci sequence is still more efficiently computed using like actually much more efficiently computed using loops, but again, this is just an exercise. So here's what we'll do. So if n equals 0, we know the result. If n equals 0, the result is 0. And if n equals 1, we know the result. The result is 1. And if we wanted to, we could hard code some other cases. We could say 2 is 1. We could say if n equals 3, the result is 1. Or result is 2. But eventually, right, we can't code in every single case, so we're going to have to use recursion. And we only need these two cases, as we'll see in just a second. So the Fibonacci number, the nth Fibonacci number, is the same as the sum of the previous two. So all I need to do is return Fibonacci of n minus 1 plus Fibonacci of n minus 2. And if I could spell, we would have a working solution. So that is how we could do this one. Notice how we do need two base cases, because if we think about it right, if n equals 0, we're good, n equals 1, we're good, but if n equals 2, then I'm calling Fibonacci of 2 minus 1 equals 1, plus Fibonacci of 2 minus 2 equals 0. So 0 and 1 have to be already known in order for me to call 2, or anything higher than 2. So that's how we could do this one. Alright, so we have bunnies standing in a line, numbered 1, 2, 3, etc. The odd bunnies have the normal 2 ears. The even bunnies have 3 ears because they each have a raised foot. Recursively return the number of ears in the bunny line, 1 through n, without loops or multiplication. Okay, pause and try this. Alright, so let's think about our base case. If we have 0 bunnies, so if bunnies equals 0, then we have 0 ears. And I think that's the only base case we'll need. And then here's what we'll do. So I'll say if the number of bunnies, think about this, if the number of bunnies is odd, then we have the same amount. So I can think about the number I'm currently looking at. I'll call it n. This is the number of bunnies in the bunny line. So if I have n bunnies in my bunny line, if n is odd, then I have the number of ears I have is the same as as 2 plus the number of ears I would have if I had n minus 1 bunnies. But if n is even, then the number of ears I have is 3 plus the number of ears I would have if I had n minus 1 bunnies. Okay, so that's what I'm going to implement here, because I basically have to do two different things if n is even or n is odd. So if n is even, I'll do the even case first. Then I need to return, right, even bunnies count as 3, so I'm going to say return 3 plus however many ears I should have if I had n minus 1 bunnies. And then otherwise return 2 plus the number of ears I would have. Okay, and that's how we could do this one here. I could, of course, get rid of that else. And if you wanted to, we could factor this out. I could say next, I'll call it equals, I'll say next equals this, this here. And I could say plus 3 plus next, 2 plus next. If you wanted to do it like that, you could. And honestly, if you wanted to, we could say, we could use the ternary operator. I could say n remainder 2 is 0, return 3 plus next, otherwise return 2 plus next. Right, and another equivalent way to do this, also using the ternary operator, would be to do, to first get a number, 3 or 2, based on whether n is even or odd, and then add next to the result. So if n is even, 3, otherwise 2, and then just add next to that. And we have to put these in parentheses because of precedence reasons. So yeah, that's another way of doing this. So, yeah, that is how we could do this one. Alright, so we have a triangle. We have triangle. Not a triangle, we have triangle made of blocks. The topmost row has 1 block, the next row down has 2, the next row down has 3, and so on. Compute recursively the total number of blocks in such a triangle with a given number of rows. Okay, pause and try this. So there is actually a formula. You obviously shouldn't do this, you should actually do it recursively. But there's a formula. We could do rows times rows minus 1, or sorry. Yeah, no, sorry, rows times rows plus 1 divided by 2. That's a formula that actually is equivalent to this here. But obviously we're going to do this recursively. So if I have 0 rows, I have 0 blocks. I need 0 blocks. And then all I need for the for a pyramid, of height n is just I'm going to call this the height of the pyramid. N is just well, I'm going to need. I can imagine like okay, so a pyramid, let's say of height 4, is the same as just a pyramid of height 3 with 4 blocks added at the bottom. So that's how I'm going to think about this. I'm going to say, okay, so if I want a pyramid of height 4, I just take a pyramid of height 3, or okay, a triangle of height 3, and I add 4 blocks at the bottom. So in other words, a triangle of height n is the same as n blocks at the bottom plus a triangle of size n minus 1 sitting on top of it. And so there we go. That's how we could do this one. All right, so return the sum of a number of n's digits. Okay, pause and try this one. Okay, so again, you could do this iteratively. That means iteratively means non-recursively or with loops, with iteration. So you could do it that way, and you probably should if you were actually coding this. But again, these are exercises in recursion. Eventually, we'll get to stuff that you actually should use recursion on, and I'll tell you when that is, if I remember. Okay, so we need to sum the digits. So we have a non-negative int n, and we need to sum the digits. So here's what we could do. Our base case could be if n is less than 10, and we know it's non-negative, so I don't care about negative numbers. But if n is less than 10, then n must be a one-digit number, right? So I know that the sum of n's digits is just n, right? Because the sum of the digits in 7 is 7, of 3 is 3, of 0 is 0, of 9 is 9. So I can just return n. And then otherwise, the current digit is going to be n remainder 10. And so all I need to do is if I want to chop off the last digit, I can say n over 10, some digits, n over 10, plus the current digit. So, right, in other words, if I want to, let's say I want to get the sum of the digits in 1, 2, 6, all I'm saying here is return 6 plus the sum of the digits in 12. And then to get the sum of the digits in 12, I'm saying return 2 plus the sum of the digits in 1. So I'm chopping off a digit every time I recursively call down. And that's how we could do this one. Also, I just noticed, do they give you a star whenever you do they give you a star every third problem? I think they do. I'm actually just now realizing this, because I know you have a 1 star for every 3 problems here, but I didn't know the star actually symbol appeared when you got every third one, I think. I don't know, I've done this a while and I've never actually figured out when the stars happen. But I think that might be why. Okay. So yeah, so this is how we could do this problem here. All right. So given a non-negative int n, return the count of the occurrences of 7 as a digit. So for example, 717 yields 2. Pause and try this one. All right, so let's see the number of occurrences of 7 as a digit. So once again, I'm going to do if n is a one-digit number, then if n is 7, I'm going to do some ternary stuff here. If n is 7, then I have 1 occurrence of 7. Otherwise, I have 0 occurrences of 7. All right, pretty straightforward. And then here is what I'll do. I'll say, okay, so all I need to do is, again, I'm going to chop off the last digit and get, okay, how many 7s would there be if I chopped off the last digit? And then, well, actually, let me see. Let me first get the last digit of n, which is going to be n remainder 10. And then I'm going to get an int that says, that is 1 if this digit is a 7, and 0 if it's not a 7. So 7, I'll just call it, okay, that's probably not a good name for a variable 7. And I don't even know what to call it though. I'll call it add. Int add equals, if the digit is 7, that should be 1. Otherwise, this should be 0. And now all I can do is I can say return whether or not I have a 7 here, 1 if I have a 7, 0 if I don't, plus the number of 7s I have if I chop off the last digit. Okay, so I want to see if I can simplify this a bit. Okay. So first, let's rewrite this bottom part here. So one other way I could do this is I could say, I'll comment this out. I could say, okay, if the last digit in remainder 10 is 7, then return 1 plus count however many 7s I have if I were to take off the last digit. And then otherwise return just the number of 7s, because I know I'm basically adding 0 here because 0 would be my add. I would not have a 7 as the last digit currently. So this is how we could do this one. Another way of writing it, perhaps so it's a little more easier to read because it doesn't use the ternaries and stuff. Um, so there's that as well. And I think I could also change this to have if n equals 0 here, and then just say if n equals 0, return 0, because if the number is 0, if n is 0, then 0 does not have any 7s in it. So that's another way of doing it. That's equivalent. Now what's going to happen is if n is a one-digit number, I'm going to see if it is, so we know that if n is one digit, then in remainder 10 is just n. So if that number is 7, then just return 1 plus count 7. And when you divide a one-digit number by 10 using int division, you get 0. And so if n equals 0, just we're done. Return 0. In this case, we'll basically handle the possibility of A, they just passed us 0 directly, or B, they were chopping off digits and they, um, got to a one-digit number and they tried to chop it off again by dividing by 10 and they ended up with 0. So it handles both, ideas in one if statement. So that is how we could do this one. All right, so compute the number of occurrences of 8 as a digit, except that an 8 with another 8 immediately to its left counts double. So 8818 yields 4. Okay, a bit of an interesting one. Pause and try this. Okay, so here's what we can do. I think we can do the n equals 1 strategy, or sorry, n equals 0 strategy again, in which case we're going to have 0. So, okay. So, if I'll also have a base or a case that says if n is less than 10, and actually I'll just merge this in with this case. So I'll only have one base case, which is if n is less than 10, then basically if n is 8, then yield 1, otherwise yield 0. I could do that as a ternary if I wanted to. But that's my base case. And so now all I need to do is, now I know that if I get down to where my cursor is here, then I know that n is a two-digit number, which means there might be, if I'm looking at the last digit, it might be an 8, and the digit before it might be an 8. So here's what I'll do. If you want to get the last two digits number, just how like if we wanted the last one digit, we did remainder 10. If you want to get the last two digits, we can do remainder 100. So I'll say if in remainder 100 is 88, this will mean, in other words, if the last two digits are 88, then I want to return 2 plus the next count, which is going to be count 8 of n over 10 if I chopped off the last digit. And then otherwise, if in remainder 10 is 8, so if the last digit's 8, then I just want to count it, I don't want to count it double, so just 1 plus count 8, n over 10. And then otherwise, just don't add anything. Just in other words, add 0 here, because we did not find an 8, which is the same as just not doing anything. So that's how we could do this one here. If you wanted to like factor this out, you could do that. Say int int, call it next. I could say 2 plus next plus next plus, or just return next. You could omit these, you could omit these curly braces if you wanted to, and that'd be good too. So this is how we could do this one. And let's see. I believe, yeah, looking at what I've done now, I can actually just do if n equals 0, return 0. And that'll work, I think. Yeah, okay. Because if I have a one-digit number and I do in remainder 100, well, in remainder 100 is obviously not going to equal 88 if in is a one-digit number. So it's basically as if this if statement wasn't here when in equals a one-digit number. So that is how I could do this one. Sometimes it makes more sense to write your logic down here and then determine what the base case is. Sometimes you know the base case right away. It's just, however, is easier to write it, to think about it when you're writing. All right, given base and in that are both one or more, compute recursively without using loops the value of in to the power. To the value of base to the in power. Okay. So power in 3, 2 is 3 to the power 2, which is 9. Okay. Pause and try this one. All right, so basically the recursive fact that we're going to take advantage of is that if I'll use b for base, in for the power, so that the fact is that b to the power n, b to the power n, is the same as b times b to the power n minus 1. So yeah, and this is actually true. I guess this is actually true for all real number, for all for all real values of n. But this actually guarantees us that n is going to be 1 or more. So if n equals 1, what I'm going to do is I'm just going to say, okay, that would be b to the power 1, which is just b. So I'll actually rename my variables b and n so it's clearer. Okay, so if n equals 1, if the power is 1, then I just return the base, because the base to the power 1 is just the base. Okay, and otherwise all I need to do is return the base times the base to the power n minus 1. So that is how we could do this one. And yeah, I think we do get the star every third problem, yeah. Okay, so given a string, compute recursively the number of lowercase x chars. Pause and try this one. All right, so the strategy here is to say, okay, is the last character, you could also do the first character, is the last character an x? If so, then return 1 plus the number of x's in all the characters excluding the last. Otherwise, just return the number of x characters in the string excluding the last character. So let's go ahead and do that. And then if the string is empty, that'll be our base case. If the string is empty, then it of course has no x's. So return 0. And then what I'll do is I'll just say, okay, if the last character, I'll call it char last, which is the last character in my string. If the last character is x, then return 1 plus the number of x's in the substring from 0 to the length minus 1. So basically get rid of the last character. Otherwise, I just need to return the number of x's from 0 to length minus 1. So that's how we could do this one. And I would again like to factor this out here and say int next equals that. And I can just say return 1 plus next or next. And so that's how we could do this one. Yeah, again, don't feel bad if you didn't see that strategy right away, or that took you a while to figure out that, hey, I could, do look at one x and then return it, do the string excluding that x. It can be hard to see the solution on your first go around, but eventually you'll get used to it as you see more examples. All right, so given a string, compute recursively the number of times lowercase hi appears in the string. Pause and try this. All right, so let's go ahead and do it. So if the string is empty, it contains no hi's. So I just can return 0. Okay, so otherwise the string is not empty. So if the string ends with hi, I'm gonna look at the end and keep going through. So if it ends with hi, then what I'll do is I'll just say, okay, I found one hi, and I'll just say return 1 plus the number of highs if I were to omit the last character. Now I could omit hi entirely, but this means I'm going to be subtracting 2 characters from the end, which means I'd have to add another base case. And I can do that. I can say if stir dot, instead of saying stir dot is empty, I can say if stir dot length is less than or equal to 1, return 0, because obviously one character string cannot have hi. So that's another base case I could do, which lets me do basically in here, instead of this return statement, what I can do is I can just say, okay, I found a hi at the end of the string, so now return the number of highs in the whole string, excluding those last 2 characters, excluding that hi that I just found. So substring from 0 to the length minus 2, because hi is 2 characters. And then otherwise, I just want to return the number of highs. Don't add 1, but the number of highs if I were to take away the last character. And I just want to take away the last 1 character. I can't like take away 2 characters, because like for example in this string, I would look and see if it ends with hi. It doesn't. If I took away 2 characters, I'd now only be considering this. And this also doesn't end with hi, so I'd take away 2 characters again. And then this does end with hi, so I'd add 1, and take away 2 characters, and then I'd be here. And so I'd only find 1 hi when clearly this string has 2 highs. So I can only take off 1 character, so that I look at this whole string, then I take off the x, then I look at this string, and I find the hi. So that's how we could do this one here. Note that I could also only subtract 1 here, and it would be fine. But I'll subtract 2 because I know that obviously there's not going to be a hi. Like highs can't overlap, so I can subtract the whole length of hi. And I can't really factor this out because these calls are slightly different. So I can't factor out this part. By the way, in programming, when you factor out code or rename things or like in any way kind of modify code that already works, but like to clean it up, to improve it, to make it more perhaps readable or maintainable or intuitive. So you're not changing the logic of the code, you're just rewriting things like turning things into variables or taking things out of variable, like rewriting things using variables or stuff like that, where you're not changing the logic of the code, you're just cleaning it up. That's called refactoring in coding, and it's kind of related to like factoring in math, how we factor out stuff from equations sometimes, or expressions sometimes. Okay, and they gave you an example solution here as well. So let's see, okay, so yeah, they did a strategy like I used a while ago with when I said like int add, where they have a number that's going to be equal to 0 or 1, whether or not the string ends with hi. And what they did is they checked at the beginning. So what they did is they were checking like starting at the beginning. I've been checking at the end. Does it end with hi? But they did if it starts with hi, which is another valid way to do it. All right. So return a new string where all the lowercase x chars have been changed to lowercase y chars. Pause and try this one. Okay. So let's go ahead and do this one. So again, this is one where it might be kind of hard to think about the strategy. But I'll go ahead and tell you a strategy. So if the string is empty, then we know that the string we want to return is just the empty string. I could also say return stir here, since I know stir is empty. So just return the empty string if it's empty. Okay, so now what I want to do is I'm going to go through this string, and I'm going to look at the characters, and I'm going to say, okay, if I'll start at the end again, just because I like to do that. If the string ends with an x, what I'm going to do is I'm going to return whatever, I'm going to take whatever this would be if I changed x to y plus a y, if that makes sense. So I'm going to look at this string, I'm going to say, okay, the last character is an x, so take away the last character, change the x's to y in this part that I've highlighted using a recursive call, and then add a y to it. And then similarly, let's do like this one here. Okay, last character is an x, so return this with x's changed to y, sorry, not that, this with x's changed to y's plus a y. And this with x's changed to y's is going to be this right here. And that'll be done recursively. So, yeah, all you really need to do is reframe the problem in terms of itself, which just sounds cool. I don't know. Okay, so let's do this. So if the string ends with a y, then I need to change the x's to y's the in the string from 0 to the length minus 1, so everything but the last character, and then add a y at the end. And I need to do it in this order. Obviously, I can't concatenate the y first because I'm doing it based on the end of the string. And then otherwise, the string does not end with a y. So here's what I'm going to do. I want to leave that other character, that character that's currently at the end, I want to leave it unchanged. So I'm going to do something similar to this. I'm going to just take the first part and change the x's to y's, but instead of adding y to the end, I'm just going to add whatever's there because I want to leave it unchanged. And sorry, I'm changing x's to y's, so if it ends with x, change it to y. Plus the character that's already at, already at the end of the string, minus 1. Yeah, so that's going to span multiple lines, but that is how we could do this one here. So yeah, that is the strategy. If the last character is a y, then add a y and change the rest. If the last character is not a y, not an x, then leave it unchanged and change x's to y's in the rest of the string. So that is the strategy here. Okay, so yeah, that is all we need to talk about there. All right, so given a string, compute recursively a new string where all occurrences of pi have been replaced by 3.14. Pause and try this one. Okay, so let's do this one. Okay, so what I'm going to do, I'll go ahead and do this one using starts with, like starting at the beginning, just to give you some variety in your problems. There's no real benefit to doing either one in this case. So yeah, and by the way, just as a side note, if you want to actually do this, you should just do replace pi with 3.14 would be a better way to do it. But of course, again, this is an exercise to practice recursion. So first of all, if the string is empty, or actually if the string's length is less than or equal to 1, then I know it cannot have pi anywhere, so I'm just going to return the string unchanged. Okay. And now if the string starts with pi, then I need to return 3.14 plus the rest of the string with pi's, with pi's changed to 3.14s. So I'm going to return 3.14 plus whatever the rest of the string would be after changing pi's to 3.14. So change pi and the rest of the string, so that's a substring from 2 to the end. And then otherwise I just need to return the first character plus change the rest of the string. So start at substring 1. And that's how we could do this one. This will just chop off basically the first char and look through the rest of the string. So that's how we could do this one. All right, remove all the X chars. Pause and try this. All right, so of course you know that if you are actually coding this, you should use the replace method. But let's go ahead and do this recursively. So if the string is empty, it of course has no X chars. And then if it starts with an X, what I want to do is I just want to remove all the X's from the rest of the string. I don't want to add anything to the string because I'm removing it. So I just want to say no X's with the rest of the string, right? Because if I say I had any string like X ABC, where it's like X followed by something, well, removing all the X's from X ABC is the same as removing all the X's from just ABC, right? If I removed that first X and then called no X, the result would be the same as if I didn't have that first X there. So I'm just going to say if the first character is an X, well, I know that's equivalent to asking no X's where I don't include the first character because it's an X. And then otherwise it does not start with an X, and I just need to include the first character, still include the first character because it's not an X, plus removing everything X's from everywhere else in the string. Substring 1. And there we go, there. All right, so given an array of ints, compute recursively if the array contains 6. All right, and this one's a bit interesting because they give you this extra parameter that we definitely wouldn't need if we were doing this iteratively. So yeah, this index is always going to start as 0, and you can use this index as you wish in order to implement this method. So this is a bit different than ones we've done before. Go ahead and pause and try this. All right, so before, with the string problems, we didn't really need this index variable because we could chop off characters from the string, right? But you can't exactly do that with arrays. We don't have like a subarray method. Um, so we're going to do this with just passing a separate index. And this will actually be more efficient than if we use subarrays, like if there was a subarray method, because a subarray method would have to copy all the elements into a new array. And that would just be a lot of copying that we don't need to do. So let's do this problem here. So if, let's see, so if index is equal to the length of the array, this is sort of a weird base case, sort of an interesting one. But basically, index is going to increase through the array, right? It's going to start at 0 and increment through the array. So if we reach the end of the array, then index is going to be equal to nums.length. And if we reach the end of the array, then we know that the subsection of the array from the current value of index to its end is does not contain any 6s because we're at the end, right? There's nothing in that subarray from index to the end. So I return false. So what I'm going to do now is I'm going to say return true if I'm currently at a 6. So if I have a 6 here, or I have a 6 later in the array. So I'm going to say if I have a 6 at the subarray starting from index plus 1. So in other words, anywhere past the current index. And that's how we could do this one here. Again, don't feel bad if if you didn't come up with this strategy right away. But yeah, that is how we could do this one. All right, compute recursively the number of times the value 11 appears in the array. Okay, pause and try this one. Okay, let's do it. So this is going to be, okay, so again, of course, we were doing this iteratively, get a count variable, loop through it, increment count whenever you find an 11. Okay, but we know how to do that because we've done that in the array1 section. So let's think about how we could do this here. So again, our base case is going to be if index is equal to the length of the array, then I have no 11s in the range from index to the end of the array because I'm at the end of the array. Okay, so what I'm going to do is I'm going to say if I'm currently looking at an 11. So if I have an 11 right here, then the total number of 11s in my whole array is going to be 1 plus the number of 11s in the array starting at index plus 1. So array 11 starting at index plus 1. And then otherwise, all I need to do is say, okay, well, I don't have an 11 here, so just look through the rest of the array and tell me how many 11s there are in the rest of the array. So nums index plus 1 and array 11. And there we go. That's how we could do this one. If you wanted to factor this out and say int not, or sorry, remaining, I'll call this remaining 11s, which is the 11s remaining in the array, or yeah, that come after this spot. So I'll say equals that. Oops, I copied it. Equals that. So 1 plus the remaining 11s, otherwise just return the remaining 11s. And that's how we could do this. All right. Compute recursively if the array contains somewhere a value followed in the array by that value times 10. We'll use the convention. Okay, and then it tells you the same thing with the index. Okay, so pause and try this one. All right, let's do it. So if we're at, let's see. Well, if index equals 0, well, I have a couple things I want to do. So here's what my strategy will be. Yeah, actually, let me think about it for a second. Okay, so here's what my strategy is going to be. I'm going to see if starting at index, which index starts at 0, is there a value at index where the next value at index plus 1 is 10 times that value. That's basically what I want to do. But this means that if index is at the last index in the array. So I don't mean at the length of the array, but I mean if it's one before the array, like so say index is at this number here, I don't want to look here because I don't want to check the next number because there's no next number. I can't check the next number. It's just like when we were looping, we stopped one before the end of the array. Sometimes if we had to look at one character ahead, we stopped two before the end if we wanted to look two characters ahead and stuff like that. So what I'm going to do, instead of saying if nums equals, if index equals nums.length, I'll say if index is greater than or equal to nums.length minus 1, then stop searching. So we have not found it of it in this subsection of the array, the subsection from index to the end. So we definitely cannot have a number followed by 10 times that number. And then otherwise, if I can say if nums at index, or I'll say nums if the next number is 10 times the current one, nums at index, return true. We have found it at index, at the current value, at the current index. And otherwise, just search the rest of the array. Just search through the return array to 20 nums and index plus 1. Search through the rest of the array. And that's how we could do this one. And of course, we could combine these if statements. We could say return if I have a number followed by 10 times itself here, or there is something in the rest of the array. And this short circuiting is actually going to make our code a little more efficient for us, because if I find it here, if I find the thing I need here, then I'm done. It's not going to even evaluate this recursive call, which is going to make it more efficient. So that's how we could do that one. All right, compute a string where all of the adjacent chars are now separated by an asterisk. Pause and try this one. Okay, so this one, again, a little different than stuff we've done before. So here's what I'll do. I'll say if the length of the string is, like I'm just imagining, base cases where I don't have to really do anything, or just I know the result. If the length of the string is 1 or 0, so if it's empty or it has one character, I just return the string, not twice. No return. I just return the string. Okay, so that's great. And then here's what I'll do. So I'll basically say, okay, so imagine I had a string, let's say I had some overlapping stuff here. Let's say I had, if I was given the input A, B, C, the output would be A star, B star, C, right? That'd be the result. So notice that this is equivalent, well, first of all, before we talk about it, if to give you another example, if I had BC was my input, the output I'd expect was B star C, right? So notice that if I have an extra A at the front, so if I have a character at the front, it's the same as just adding A star to the front and then getting what the result would be if I didn't have that character at the front. So you see how these are the same. So all I did to find ABC, to find what the result should be if I'm given the input ABC, is I just said take the first character, add a star after it, and then figure out what the result would be if you just did the remaining characters of my original string, which we know that result would be B star C. So that's basically where the recursion is going to come in here. So I'll call it, I'll say return the first character plus a star plus the remaining string interspersed with stars, so allStar substring1. And that's how we could do this one. All right, compute recursively a new string where identical chars that are adjacent are separated from each other by a star. Pause and try this one. Okay, so my base case again is going to be if the length is less than or equal to 1, in which case I'm just going to return the given string. Okay, so now what I need to do is I need to also look ahead at the next character. So let's first do the case where I don't have duplicate characters, where I don't have two characters in a row. So if the first character does not equal the second character, and I'll actually make these variables char first equals char at 0, and second is going to be char at 1. Okay, so if the first does not equal the second, then what I want to do is I just want to keep the first char the same. So first plus putting stars where you need to put them in the rest of the string. So that's all I need to do if first does not equal second. Okay, and then otherwise, here's what I'll do. So otherwise I know first equals second. So what I need to return is I need to do first plus a star plus second, and I could also put first here because I know first and second are equal. So first plus a star plus second. So now I've interspersed a star between them. Plus, oh, and by the way, this should be substring1 plus, and then I'm basically going to say look through, well, actually, wait, I don't need to put second here. All I need to do is say pairStar from the substring from 1 to the end. So I'm basically saying, okay, if you're at a character and the next character is the same, put a star after this character. And putting a star after the current character will effectively put a star between those two identical characters. And let's see, what is it actually called? pairStar, did I not? Oh, pairStar. Okay, there we go. That is how we could do this one. And again, if you wanted to factor this out, you could say like string remaining equals this. First plus remaining, first plus star plus remaining. And there you go. Alright, so compute recursively a new string where all the lowercase x stars have been moved to the end of the string. Ooh, this one is interesting. Pause and try this. Alright, so x is moved to the end of the string. Let's see here. So once again, if the length of the string is less than or equal to 1, we can just return str, right? Because if the string is empty, we just return the empty string. If the string is a length of one string containing just x, well, all the x's already are at the end of the string. And if the string is a length one string that is not just x, like it's a different character than x, then there are no x's. I don't have to do anything. So that's going to be my base case. And then I need to move the x stars to the end of the string. So here's how I'll approach this. So if the first character, I'll call it first, char first. So if the first character is an x, here's what I'll do. Here's going to be my strategy. I'm going to just, I'm going to move everything. I'm just going to look at the remaining string, remove all the x's to the end of that string, and then add my x to the end of that, right? Because I can just dump all the x's at the end. So I'm going to say return endX if I do everything except the first, plus just adding my x at the end, plus I'll just add an x at the end. And that way, I've basically done everything else first, and then add this x at the end. So this x effectively moves to the end. And that is how, or that's what we would do if we had x as the first character. And then otherwise, here's what we can do. We just basically don't want to do anything. We want to skip over this character. So all I'm going to do is say first plus index str.substring1. So just, I don't care what's going on at this character because it's not an x. Move everything else, all the other x's after this to the end. And that's what I'll do there. And make sure to spell. Okay, so that is how we could do this one. Sorry, my voice is still kind of like uh, not fully recovered. I've been doing a lot of CodingBat recording. Okay, so that is how we could do this one. Let's see, anything else to talk about here? Yeah, this is, again, not something that maybe comes naturally to you, but hopefully you can understand why these solutions work here. Okay, so a pair in a string is two instances of a char separated by a char. So AXA, the A's make a pair. Pairs can overlap. So AXA can contains 3 pairs, 2 for A and 1 for X. Recursively compute the number of pairs in the given string. Pause and try this one. Okay, let's do it. So, if the length of the string is less than or equal to 2, then it cannot have any pairs. So that'll be our base case. And then what I'll do is I'll say if, I'll get the first character and the third character, basically. So the first character is going to be char at 0, and the third character is going to be char at 2. Okay, so if the first character equals the third character, I'm just testing, do I have a pair that starts at the beginning of the string? So if the first equals the third, then I return 1 plus the number of pairs remaining in the string. And I can't skip past the whole pair, because pairs might be overlapped. So what I do is I just do start.substring1. I just take out the very first character and look through the rest of the string. And then otherwise I just return the number of pairs found in the rest of the string, because there's no pair starting at this index. So that's how we could do, if I spell correctly, that is how we could do this one. Alright, so the total number of ABC and ABA substrings that appear in the given string. Pause and try this. Okay, so if the length of the string is less than or equal to 2, we do not have any such strings. So all I need to do is say if the string starts with ABC or the string starts with ABA, then we found a match, and I'll need to skip it. I'll return 1 plus the number of matches I find in the remaining string. Now, let's think about what we need to do here, right? So we could just skip 1 ahead, and that would be fine. So I could just say, like, chop out the first character and look through. I'll just say count ABC stir dot substring 1. We could actually do a little better. I'll come back to that at the end. So otherwise, if the string doesn't start with ABC or ABA, then I just want to skip the first character and look through the rest of the string. And again, spelling is my specialty. Okay, so that is how we could do this one. Now, let's think about this here, right? Can I just skip past the whole 3 characters? I found ABC or ABA. Can I just skip past them? And the answer is no, I can't. You'll actually see that I fail a test case. If I just skip past all 3, I fail this test case specifically. And that's because these 2 strings actually can overlap with each other, right? Because ABA could overlap with ABA, because this last A of 1 could be the first A of something like ABC. So I can't take off the first 3 characters. Like, I can't skip over all 3 characters, but I can't skip over the first 2, because the first 2 in both are AB, and AB cannot overlap with itself. So I could skip the first 2, and it would still work. So that's how we could do this one. All right, the number of 11 substrings in the given string. And this one specifically says they should not overlap. Okay, so pause and try this. All right, so if the length of the string is less than or equal to 1, I have no 11s. And then I just say if the string starts with 11, then I've found 111 plus the number of 11s that remain, and we make sure to do start out substring 2 and not 1, so that we don't count any overlapping strings. And then otherwise, I just return the number of 11s that remain in the string, only skipping the first character. So that is how we can do this one. All right, return a recursively cleaned string where adjacent chars that are the same have been reduced to a single char. Pause and try this. All right, so if the length is less than 1, less than or equal to 1, then I can just return the string. And then what I'll do is I'll say, I'll get the first char and the second char. I'll say 0 and char at 1. Okay, so if the first equals the second, then what I'm going to do is I'm just going to basically skip one of them. I'm going to skip the second char. I'll just say return first plus stringClean, and then I'll start at index 2. So this way I'm effectively effectively omitting the second char, because I'm just saying first char, return the first char plus whatever you get if you clean everything starting at index 2. So we're not even caring about the second char there. And then if the first does not equal the second, we return first plus what we get if we clean the rest of the string. And let's see what I've done here. So we say, let's see. Okay, so if you have something like this, where you have 3 in a row, this doesn't work. Let's see. Oh, so what we actually want to do here is, instead of doing that, we can just say clean 1 here. Okay, so what was going on there is that if I had what I first told you, so let's say I get to a situation where I have 3 in a row, or more than 3 in a row, I'm basically including this character and then saying, okay, clean the rest of the string. But if you clean the string ZA, you still have ZA. So basically I have Z plus ZA, which still leaves me with 2 Z's adjacent to each other. So what I want to do instead is go ahead and just omit the first character and then return the rest of the string cleaned. Because now if I see, okay, I have 2 Z's in a row, so then just clean the rest of it, return the rest of it cleaned. And I say, okay, I have 2 Z's together, so return the rest of it cleaned. And then the rest of it cleaned is just ZA. And that just gives me ZA, no duplicate Z's. And then you could factor this call out if you wanted to. So that's how we could do this one here. Alright, so the number of times lowercase hi appears in the string, but don't count hi's that have an x immediately before them. Pause and try this one. Okay, so if the length of the string is less than or equal to 1, then I just need to return the string. Or sorry, not the string. I just need to return 0. And the strings have to not have an x right before them. So what I'm going to do is I'm going to say, okay, does this string start with, does it either start with hi, or does it start with some non-x character followed by hi? And actually, yeah, so, and the thing is, if we find a non-x character followed by hi, we're going to have to skip past the end of the hi so that we don't, count it twice. So if the string currently starts with hi, and actually what I'll say is if, I'll just say if the string equals hi, so if it's a length 2 string, because I know that the string's length is not less than or equal to 1, but it still might be 2. And if it's 2, I just want to return 1 if it equals hi. And in fact, actually, I think I'm just going to say starts with instead. Yeah, I'm going to stick with my original plan. So if it starts with hi, then I'm going to return 1. And then otherwise, I'm going to see, okay, does it have an x followed by, and actually, wait, to make this a bit clearer, I think what I have right now would work, my idea would work, but to make this clearer, I'm going to actually just have a separate base case for length 2. It's just going to be clearer. So if it's length 2, then I just say if the string is hi, return 1, else return 0. I think we could make this more concise, like by doing it another way, but this I think is just clear what's going on. So I'm just going to leave it like this. Okay. Okay, so now we can actually get down to business. So I'm going to check if the string starts with a non-x character followed by hi. So if, I'll say char first equals the first character. So if the first one does not equal x, and the substring from 1 to 3 is hi, then what I'll do is I'll just say return 1, I found 1, plus the number of highs, not followed by x's, that occur elsewhere in the string. So what I'll do actually is I could have two highs in a row. Like I could have um, x high high, and that would have one valid eligible high. So what I'll do is I'll only skip the first two characters there. So if like I have, there's no example that has that, so let me write one out here. So say I had, my input was x high high. Well, if I look at this first one and I say, okay, it starts with x high, which is not eligible high. So if I then said, cross this out and look here, then I would see that, let's see, I would see that I would not basically have a valid high if I looked at this string. Let's assume that there are other characters that I know technically because of my base case um, of length 2 that would work. But okay, so I start and I say, okay, I found an x high, so I chop it off, and then I try to look. Okay, does this string right now, does it start with xhi, or sorry, a non-x character and then high? No, it doesn't. So it wouldn't work. So what I need to do is I'm only going to chop off. I'm only going to chop off the first two characters. So I'm just going to say like that. And then it will detect this high because it has an I before it, which is not an X. So if the first character is not an X and there's a high after it, then what I want to do is I just want to chop off the first two characters, but not the first three. So I'll say countHi 2, substring starting at 2. And then otherwise, I just want to keep going through. Just go on to the next one. So return countHi 2 from str.substring1. Okay, and let's see here. So this is running to, let's see. So otherwise, let's see. Okay, so if I don't have a non-x followed by high, then let's see, then what I want to do is otherwise, if my, here's what I'll do. I'll also have a just a case for if the length is 3. So if the length is 3, I might be getting a little too many base cases. There are definitely better ways to do this. So if the length is 3 and the string ends with high, sorry, so if the first character is not an X, 0 is not an X, and it ends with high, then return 1. Otherwise, let's see. I could still have a high at the start. So if starts with high, return 1, otherwise return 0. I have a feeling this is still not going to work. Yeah, okay. So let me rethink this here. You can just see live thinking. I know, very exciting. Okay, so let's see exactly how I want to do this. So here's what I could do, I think. Here's another idea that I had. Is if it starts with an X, so what I'm going to do is I'm going to say, okay, I'm going to test if there's a high at the start of the string. But what I'm going to do is whenever I find an X, instead of, making the next recursive call start at substring, str.substring1, I'm going to make it start at str.substring2. So I skip the next character, so that the next, spot after the X is not an eligible spot for me to look for high. I think that's a better way to do it. So I'm going to say if stir starts with an X, then we obviously don't have a high. Like we were going to skip the next character, is what I'm going to say. So return countHi 2, but skipping the next character. So take the substring starting at index 2. And then otherwise, if starts with hi, then just return 1 plus the number of highs that remain. So countHi. We can also skip the first 2 characters because I know they're high. And then otherwise just return countHi if you were to keep looking through the string. Substring 1, countHi 2, please. 2. Okay, so that still does not work, and that's because I have, let's see, this is running 1. Oh, because if I have an X, there might be an X right after it. That's actually good. Good test case there. Okay, so let's see. So it starts with an X. I want to, let's see. If it starts with an X, I can say, this is kind of getting a little messy, but I can say if the next character is an X, so try at 1 is also an X, then just return countHi. Oops. Oh no. Return countHi starting at substring 1. And I know if I do this, then I start at substring 1. Well, I know that the string I'm passing back to the recursive call also starts with X because I just verified it here. So I'll be fine. And I think, yeah, that's how I could do it. This really is not the most elegant way to do it. I think I was on to something at the beginning, like with the checking, okay, is there a non-X character followed by high at the start of the string? The only problem is just like the length to string that just contains high, and then like, yeah, I don't know. Okay, I want to try that, but at the same time, I don't want to, spend a bunch of time debugging. So I'm gonna actually pause the video and see if I can figure out how to do it that way. Okay, so I didn't quite find a way to do it using the strategy I was talking about earlier. But if you look starting from the end instead of at the beginning, you can actually do it pretty easily. So that's what this is here. This if statement goes on to multiple lines, so it's kind of annoying. And I still can't even fit it on like that. Maybe I could do 75 and then really zoom in. Okay, here we're really zoomed in here. Okay, so here's what we'll do. So we can see what's happening. So same base case. But I'm gonna start from the end. So I'm gonna say, okay, if it ends with a high, and either, that high is at the very beginning of the string, like the string's length is only 2, or the character before that high is not an X, then we found a high, 1. So if it ends with a high and either the string's only length 2 or the character before that high is not an X, then return 1 plus the number of highs in the string, and we can skip these last 2 characters because they're high. And in fact, we don't need to skip the last 2. If I run and move over, it would still work. I know I'm super zoomed in. But yeah, we can ignore the last 2 characters because I know they're high. And then otherwise, just count the number of highs from 0 to like the length minus 1. So in other words, ignoring the last character. That's how we could do this one. And this one's quite straightforward, actually. So, I mean, this statement's kind of messy, but we're kind of long. So that's how we could do this one. And I like this solution actually a lot. I like it more than the original one I showed you. But yeah, I couldn't figure out a way to do it where like you check if there is a non-X character followed by high at the start of the string, because it just gets hard because like how do you know that, like how do you differentiate between when the original string you were passed in just started with high, or is this like a recursive call where like you had high where like the previous character might have been an X, but now the start of the string is high because they've chopped off the first character. It's just weird. I couldn't quite figure it out, but perhaps there is a way to do it that way. And yeah, again, like I'd love to keep recording while I'm debugging and trying things out, but like it might take me an hour and end up fruitless, and I don't want to, just have an hour of that in the video, because like it might be valuable to you, but probably not. So yeah, we'll keep on going here. So given a string that contains a single pair of parentheses, compute recursively a new string made of only the parentheses and their contents. Ooh, that's interesting. Okay, cool. Um, yeah, if you were doing this before you start, or you can pause and start now if you want to, but if you were to do this without recursion, I would suggest doing it like this, saying str.substring from the first index, or from the first index of an open parenthesis to the index of, since it guarantees me there's only one closed parenthesis, the index of the closed parenthesis plus 1. And that's how I would do this one here, if you were to not do it recursively, but you should do it recursively because that's the point of this section. So pause and try this one. Okay, so let me just go so it clears the screen on the side. So, okay, let's do this one. So, okay, how should we do this one? I need to think about this one for a while, so let's see. We want to get rid of characters at the beginning, right, until we find a part in parentheses. And then, let's see. So, like, I'm sure there is a way to do this, only in this method. Like, I could totally write a helper method that would help me do it and still be recursive. Um, but let's see here. If we want, hmm, let's think here. Yeah, this is, because like I could totally do it recursively if I had like an extra parameter I could pass in, or I had another helper method. And there's nothing wrong with writing a helper method. I just want to see, because as I said, I've done these problems before, and I remember doing this problem using recur, it's like not writing anything else. So, hmm, how should we do this? Oh, I think I had an idea. Okay, so at every iteration, not iteration because we're not doing this iteratively with loops, but at every like sort of call, what we do is we try to chop off a character from the start and the end. So like in all these problems, we've like been chopping off characters from the front or the end. Now we're going to chop off characters from the front and the end and see if we can do that on every call. That's my idea. So um, yeah, so we'll see if we can do that. So my base case here is going to be if the string is already just the thing in parentheses, like if it's already just parentheses at the beginning and end and stuff in between. So my base case, in other words, is if str.starts with an open parenthesis, and I know the string's length is at least 2 because it guarantees me I have a pair of parentheses. So if it starts with an open parenthesis and ends with a closed parenthesis, then we're good to go. We have the right string, so I just return it. And now what I do is I say, okay, if str starts with, or sorry, if str does not start with an open parenthesis, then I'm going to basically reassign str to a string that starts at index 1 so that it gets rid of that first character that's not an open parenthesis. And then I say if the string does not, sorry, this should be str dot. If the string does not end with a closed parenthesis, then reassign it to a string that does not include the last character, that last non-parenthesis character. And then just say return parenBit of this remaining string. So at each iteration, we try to chop off or try to get rid of characters at the beginning or end that are not parentheses. This is an interesting problem. That was a tricky solution to figure out, and just a interesting one. I quite like this problem. Let's see their solution. Okay, so if the first character is not an open parenthesis, return it. If the last character is not a closed parenthesis, um, sorry, um, just take off the last one. Okay, so this is a similar idea, but they implemented it differently and perhaps better. So I think um, I might not even need this. Okay, I definitely need this. I was just thinking, yeah, it's gonna keep going forever. It's never gonna actually just return str. That's right. Okay, so I do definitely need that. But what they were doing, yeah, is but basically what they're doing is they're getting rid of all the fronts, the characters before the front parenthesis, by just recursively returning, chopping off the first character. And then eventually we're gonna get to a point where the str starts with a open parenthesis and we'll get past this if statement. And then we'll go through this if statement, several times from recursion, where we'll chop off ending characters. And then we'll finally get past the first two if statements and finally get down to here, which says return str. So, and just gives you back the string. So that's another clever way to do it. I like this problem. Okay. Return true if it is a nesting of 0 or more pairs of parentheses, like this. Okay, so pause and try this one. Okay, so let's do it. So basically, if we want to think about this recursively, this thing is a valid nested pair nested bit of parentheses if it starts and ends with a parenthesis and the interior characters form a valid nest. So that's basically what I'm going to do. And I'm going to say the base case is if, well, if the string is empty, well, I know a couple things, yeah. If the string is empty, it is a valid thing because it says 0 or more pairs of parentheses. And then what I'll do is I'll say if the string starts with an open parenthesis and ends with a closed parenthesis, then return if the interior characters form a valid nest. So return nestParen str.substring 1 str.length minus 1. And then one thing we'll have to be careful of is if the string has a length of 1, then it's obviously not a valid nest, so return false. You could say if the length of the string is odd, remainder 2 is not 0, then I know it's not a valid nest. I could say that as well. So that's my idea here. And then, oh yeah, and then otherwise, if the string does not start and end with parentheses, then it's obviously not a nest, so return false. And that's how we could do that one. So that's another good problem, I think. All right, so given a string and a non-empty string sub, compute recursively the number of times that sub appears in the string without the substrings overlapping. Pause and try this. Okay, so I'm gonna start from the front and just chop off stuff, try to find subs. So base case str is empty. Or actually I can say the base case is if str's length is less than sub's length, so str length less than sub length, then I know that sub does not appear in str, so I can return 0. And then what I'll just say is if str starts with sub, then I need to return 1 plus the number of subs occurring later in the string. So I'll say str.substring sub.length. Since I want to skip over subs to make sure it doesn't overlap, I'm going to start at sub.length. And then otherwise just return str.substring starting at 1, so skip the first character and just keep looking. And then, sorry, I need to pass this to the recursive call here. And that's how we could do, or nope, that is still not how we could do this one. Okay, so we also need to pass in sub here. Sub. And what have I done? I need to pass this into the recursive call as well. And I am still, okay, there we go. Now Now we have the answer. Okay. So that is how we could do this one. Man, I really say that a lot. I have like 5 phrases that I've probably said like 200 times so far this series. Like, um, what are they? There are many ways to do this. We have, there, so we could do this one. We have, pause and try this. all my phrases that I just say over and over. Okay. Um, all right. So a string and a non-empty sub compute recursively if at least n copies appear in the string somewhere, possibly overlapping. N will be non-negative. Pause and try this. Okay, so let's see how we could do this. So, okay, so what's going to be changing every time? So sub is never going to change when I recurse, obviously. So, but what might change is star might change and in might change, depending on like how we want to do this. And I think I think they're both going to have to change. So, because what I'm going to do is I'm going to say whenever I find one, decrease my goal, like if n is my target number of occurrences, um, whenever I find one, whenever I like find an occurrence of sub, decrease my target by 1, because now I need to find one less sub in order to satisfy the conditions. So one of my base cases is gonna be that I don't need to find any occurrences, which is gonna mean I return true. And then another base case, let's see, is gonna be if the length of the string is less than sub.length, then I don't have any occurrences. So I'm going to return false because I know n will be non-negative, and if n is not 0, because I checked that already, then I just don't have enough occurrences of sub, so I need to return false. And so then here's what I'll say. I'll say if I find an occurrence, and it says possibly overlapping, so if star starts with sub, then basically I'm going to return strCopies, my recursive call, and I'm going to ignore the first character. Sub's going to stay the same, but now I'm going to decrease my target, my goal, by 1. And yeah, and I'm only skipping the first character because overlapping is allowed. If overlapping was not allowed, I would skip to sub.length. And then otherwise, star does not start with sub, so just return strCopies, skip the first character, substring1, keep sub the same, and keep the goal the same. I think that'll do it. Yep. All right. And they did it pretty much the exact same way. Awesome. All right, the last problem here. Okay, so a string and a non-empty sub compute recursively the largest substring which starts and ends with sub and return its length. Ooh, interesting. Okay, pause and try this. Okay, let's see here. So what I'm going to do is I'm going to say, this is kind of like the no, not the parentheses one. The one where we had to find the text within the parentheses, and we had one pair of parentheses. It's going to be like that one. So if, and I'm going to use the kind of style that the CodingBat author solution used, because, or the CodingBat author used in his solution, because I liked that idea. So if the string does not start with sub, then we need to get rid of it. So strDist is going to be, we're going to return str.substring 1 and sub. So we're going to get rid of the first character if it doesn't start with sub already. And then if the star does not end with sub, I need to get rid of the last character because I don't want it. If the star doesn't end with sub, I need to remove characters until I'm left down with just the what am I trying to say here? Until I'm left with just the text that contains sub at the beginning, sub at the end, and some text between them possibly. So I'll say strDist, and I'll get rid of the last character because I'm going to take away characters from the end until the star ends with sub. I'm going to take away characters from the beginning until the star starts with sub. So star.substring 0 to star.length -1 and keep sub the same. Okay. And now I just need to return the length of the string because if I get past both these if statements, then I know the string starts and ends with sub, and therefore the largest substring which starts and ends with sub is just the length of the string. And let's see, what have I done here? Okay, so let's see. Oh, so 0 is a possibility. Okay, I didn't handle that. Okay, so if if the string is empty, if stir is empty, then return 0. I think I need to add that. Okay, I guess I sort of assumed that I was guaranteed 2 occurrences of sub, but I'm not. So yeah. Okay, there you go. That's how you could do this one. Um, all right, that's the Recursion-1 section, and that's the last long section. All the other ones looks like they have about 9 problems each. So yeah, there's more CodingBats. We're nearing the end. All right, hope you learned something today. Recursion's a wild world, and in the Recursion 2 section, we'll actually do stuff that you should do with recursion. That's better done with recursion, or easily done with recursion. So that is all I have today. I will see you next time for Recursion 2.